Hello. Yeah, so I'm going to talk about the FIDO Alliance. I'm pretty terrified of speaking in public, so please be gentle and at least pretend to laugh at the joke. So thank you. That's a good start.
Say first.
No, we don't. There's no. You can, if you spot the word password in the presentation, feel free to shout out. That might be fun. So I'm Dave, and I've lived here since 2010. I work for ForgeRock, who write access management software. We're based on Queen Square, and I develop a piece of software called OpenAM, which is Open Access Management Access Manager. It's based off OpenSSO, which was Sun's single sign-on solution. I quite like authentication. It's kind of an interesting topic. And I really don't like what we've ended up with, because apart from hover cars and jetpacks and fun things, kind of we don't have those things. We have bad things like kind of war and passwords. And that, yeah, we want to try and move away from that. So I'm going to introduce today, hopefully, the work done by FIDO Alliance, which doesn't really include me, although ForgeRock are a partner, member of the Alliance. And kind of just spread the word about how we're kind of hoping to move away from passwords in the future. So without further ado, let's kind of introduce the topics that we need to cover. And that is authentication. Now, most of you are familiar with it. There's some quotes from Wikipedia, because my university lecturer once told me that everything has to have a quote from Wikipedia to be kind of a nice presentation. So the act of confirming the truth of an attribute. There you go, that's a nice precise definition of authentication that I'm sure. I just noticed that the top of the slide is going off the sides. This is all James's fault, incidentally, because I had to resize these slides for 16:9 halfway through. So if there's any kind of image problems or anything, that's not my fault at all. So there are three types of knowledge base, three types of authentication. The first is knowledge base, and this is the one that you'll be using and used to. You log into everything with it. It's passwords, something that you know. Something that you know and supposedly nobody else does, although in the case of Jennifer Lawrence, unfortunately, everybody now knows that. There's two other types which are becoming more and more prominent, and they are ownership-based and inheritance-based. Ownership-based is basically something that you own, something that only you own, and something that only you have access to, ideally. And inheritance is even more precise. That's something that you are. And as you can see, there's a couple of examples there: passwords, security tokens, and fingerprints. So we'll look at why kind of passwords are terrible, and you've probably all seen enough talks on TED and so forth about why passwords are crap, but no matter what you tell users to do with regard to passwords, they will always make the easiest password available to them. And even if you make it impossible to get a good password, like get an easy to guess password, or a password that can't be broken through dictionary attacks, then it's impossible to type them on the kind of new form factor devices that people are using. So there are some great comics, great SKCD and Oatmeal comics laughing at passwords and telling you how to come up with kind of new passphrases instead that are harder to guess. And Laurie Faith Cranor has done a TED talk about kind of the impact of passwords. But in essence, if you're forcing somebody to remember 20 different things for 20 different sites, they're actually going to remember one thing and use it everywhere, because people are crap as well. It's an unfortunate truth. So the way that people have kind of tried to address this so far is through mitigation rather than actually kind of addressing the problem. Knowledge-based authentication methods can be augmented by adding on kind of additional types of authentication afterwards. So risk-based authentication is something that takes effect after your attempted login and can verify things about your login attempt. For example, are you logging in from a new computer, a new location? Are you logging in at a time of the day that you don't normally log in? Are you trying to perform actions immediately after logging in which seem somehow suspicious? If these are true, then you can trigger further authentication mechanisms to ask them to verify further. The other approach is using second factor. So if you think of the knowledge base as your first factor identification, then your second factor is hopefully an ownership or a inheritance-based factor. And you can see these in a couple of kind of Blizzard's Battlenet Authenticator uses device which you register to Blizzard using a serial, and will sync to their time server, and that'll generate random numbers for you to type in. And obviously, if you type in the right random number in the right 30-second period after having typed in your password, then they know that you're the owner of the mobile phone that they originally associated with your account, and that acts as a kind of second factor. Steam do something similar, wherein if you try and log in through a new computer, they'll send an email to your account with an obnoxiously short code to type in, and once you've typed that in, you'll be allowed to download your games and do things that people do on Steam. So we're going to try and move away from just augmenting passwords and actually replace them entirely. And we're going to do that by using the FIDO Alliance? No, FIDO Alliance. Which is not a collection of dogs, but this is what we'll go through. What it is, who's involved in it, how it works, the two specifications defined by it, which are UAF and U2F, and I'll go through those and what they stand for momentarily. And then we'll have a look at some potential problems with the implementation as suggested by the Alliance, problems that kind of I've devised. And finally, we'll look at SimpliFIDO, which is my own kind of cut-down, reduced version of their specs, which allow you to get the same kind of user experience, but without some of the hassle, which kind of we'll talk about in the problems with it. So FIDO actually stands for Fast ID Online. The image to the right pretty much covers the entire of the rest of the talk. So if you can just appreciate how beautifully succinct that is. It is passwordless authentication. It was also stolen from their website, so I didn't even make it. The idea is that you pre-register with the service, and when you register with the service, you also register a FIDO-enabled client device. And this client device, upon registration, mints you a private key and sends the public key over to the server. It then uses that to verify signed messages that you send when you subsequently log in. This means that you can authenticate to your local device rather than having to authenticate to the remote server. Simply sending the signed message is enough for them to confirm that you own the same device that you registered with them initially, and that some form of authentication has taken place on the client device. It uses PKI to do all the hard work, and secure comms channels, which basically just means HTTPS, as secure as they are, I suppose. The important kind of point of this is that the local authentication is pluggable. You can replace the thing done on the device from anything from holding up a dongle next to an NFC-enabled phone, to pressing a button, to scanning your finger, to typing in a password, to doing face recognition, iris recognition, any of those things. So the kind of pluggable local auth is the key part of the UAF spec. The U2F spec removes the kind of ability to do all the fancy biometric readings by simply allowing you to have a NFC or USB device next to your machine or on your machine. So how these able to kind of communicate, we'll go through momentarily, but first of all we'll look at who's involved in this. And as along with your phone and your DNS server and your web browser and everything else in the world, Google are the guys that actually invented it. And they are the kind of main components of the writers of the UAF spec, along with Knock Knock, who are the creators. Hello. X apparently, who are the creators of the U2F spec. Now there's a number of other partners, ARM, Discover, Identity, PayPal, Microsoft, Crucial Tech, BlackBerry, MasterCard, Bank of America. This has totally worked out brilliantly. Bank of America, RSA, I don't know if that was on, and Boardrock, who are somewhere. Should we get an icon? No. There we go. Hello. So that slide was fucking great. Let's instead stop talking about different companies and look at how the whole thing processes. And there are kind of three important stages to it. The discovery stage, the registration stage, and then the authentication stage. So discovery is the part of the protocol that allows the server to interrogate your user agent to find out what enabled clients you have nearby. And I don't really like this part of the spec, but it's incredibly necessary. It conveys information to the server from the client about its capabilities, and it requires vendor integration. And the way it does this is by putting part of the FIDO stack in your user agent. This allows websites to send a bit of JavaScript to your user agent to say, hey, interrogate all the USB devices and see if they're FIDO stacks. Activate the NFC and see if there's a FIDO-enabled device nearby. Or if you're using a mobile phone, to say, activate your FIDO application. The use of this is that it allows a server to send a challenge directly to the device itself, and the device can then, having performed its local authentication, send the response to that challenge. It adds a bit of security, but it requires vendor integration, and you might have noticed that there was a name missing from the slide previously, and they're the guys that make my laptop and my phone. And when Apple and Google don't decide to do something together from the outset, there's kind of very little chance that they'll ever decide to do something together later on. So there is this problem with discovery, which is that it requires a huge amount of pre-decided information to be included both in the hardware and in the software layers of the devices that you're using. So while Chrome supports it, currently Firefox, IE, and Opera probably doesn't. I don't know. Has anybody used Opera in the last couple of years? Has someone used Opera? Nobody uses Opera. Okay. So registration. The client indicates to the server it wishes to register. The server indicates that it requires a FIDO device or wants a FIDO device, and passes its application identifier to the user agent, which is got the FIDO enabled client side. Upon the second factor being found, and assuming that the local device authentication passes, so for example, getting a message on your phone to say you now need to scan your finger, you scan your finger, it then mints your public-private key, stores your private key in the device's private key store, sends the public key back off to the server, and you associate the private key with the application ID or the website ID, so you've got a Facebook key, and you've got a full drop key, and you've got whatever else you want, and the remote side, the server, stores your user alongside the public key. So that's the necessary parts of registration being done. We'll look in a moment about how U2F can only be used as a second factor, and UAF allows for you to do the entire login process through it. And the long and short of that is that UAF allows you to store your username in the message that you send, whereas U2F requires you to actually have done some form of authentication prior to accessing the U2F stack. So the authentication process is very similar to registration. You go to a website, the website will indicate that it requires your second factor device and pass its application identifier along with a challenge. You open up your FIDO enabled application, or you put your dongle next to your machine, and that allows it access to the private key, which then signs the challenge response and sends a message off. So it verifies the signature, and assuming that you are who you say you are and you're using the device that you say you're using, you will then gain access. Obviously this has huge benefits over passwords. It allows you to simply go to Facebook, type in your username, pull your phone out your pocket and scan your fingerprint, and that will complete the login process. There's no need for you to remember a password at any point. There's no need for you to use 200 passwords, and the phone and your fingerprint are ideally not lost or stolen. The spec does allow for ways of deregistering devices. I'm not going to go into that today. It's pretty boring and very obvious. You can unregister a device, remove the specific public key from the server, or likewise remove the private key associated with the server from your client device. So we'll look at UAF. There are sequence diagrams in this talk because we like sequence diagrams. The user's user agent is FIDO aware. It contains your UAF stack, which can be interrogated in JavaScript, everybody's favorite language, by looking at Window Navigator FIDO UAF. And you can do fun things like not Window Navigator FIDO UAF, find if it's there, which is useful. The user has a FIDO enabled device, which can be found by UAF's discovery, and the server tells the device with local authentication which local authentication procedures are allowed. So the server will say, I will accept you to use a password or a fingerprint or a retina scan. The user presents that local device authentication, and the local device is then able to store the username along with the private key and the application identifier. And that difference there, the ability for you to use biometric authentication mechanisms and store your username, is the key difference between UAF and U2F. So U2F is designed for mobile devices initially, and it doesn't allow you to select these kind of the different types that you wish to authenticate in terms of biometrics, but it does allow you to present devices to it. Knock Knock Labs have developed a USB key that you plug into the side, and it scans your thumbprint. Sorry, it doesn't scan your thumbprint at all. You plug into the side, and it has a button on the top. You press the button on the top, and that kind of saying that you're present and that you've got the FIDO-enabled client device that was initially registered is enough for the U2F spec to occur. In U2F, you can't store the username, so it can only be used as the second factor. I forgot to mention that UAF is universal authentication, and U2F is universal second factor. So those are the key differences. Are there any problems with it? Well, yeah, as I've already mentioned, it has a huge reliance on the vendors working together, which they don't like doing because they actually like having your money and not giving it to other people. So while Firefox, Safari and MSIE don't support the Google Pro standard, Chrome does, and Apple are almost certainly never going to pick this up. And that's really frustrating from somebody that likes authentication, because this helps us move away from passwords. This really is good future stuff, and we like good future stuff, but sadly, if people don't agree to use it and it's too hard for people to integrate, then they won't. So is there a way that we can remove the necessity for the user agent to be FIDO enabled? Is there a way that we can remove the challenge response but still allow for the local device biometric registration and authentication to occur? And the answer, as proposed by me, is a simplified version of FIDO called SimpliFIDO. It is a very basic implementation of the FIDO concepts. The user agent doesn't need any fancy plugins, and it doesn't rely on a challenge response mechanism to send messages. It's currently implemented, or the version that's on my laptop is currently a second factor auth only, although there's no reason why you wouldn't also be able to store your username in it. It comes as a pair of standalone mobile application, which is the application that you run on your phone, which simply says SimpliFIDO and will store your list of registered websites, as well as have access to your private key store. And the authentication module, the server module, is currently written as an OpenAM authentication module, obviously because I work for ForgeRock, and that's simply because it's the easiest way for me to write this. The spec, in terms of how it communicates, uses very basic technologies. I mean, it's PKI, JSON Web Tokens, JSON Web Signatures, stuff that you can implement all over the place without any fuss. And it works by removing the discovery part of the spec. Instead, it utilizes the user's short-term passphrases. Now, I know that I promised that we get away from passwords and we get away from you having to remember 20 different things for 20 different sites, and that is true. But it does mean that you're going to have to remember something for about 10 seconds. And that thing that you remember for about 10 seconds is your PIN. So I'll have a look quickly at the registration sequence. You say hello to the website. This is a kind of not quite too technical version of how you communicate with websites, in case you haven't picked up. And it says hello back. And it says I want to register my user with my telephone number. And this back channel communication is basically anything that will allow you to communicate with your FIDO-enabled client device. And in this case, I've used the example of SMS, though it could be done through email. Basically, you want to get a message in the form scheme, // information, over to your phone, which will then activate and run on your FIDO-enabled client application. So the SimpliFIDO registration service will generate a challenge and store a challenge response associated with the user, and it will then send, in this case, an SMS message over to the phone that you initially registered with. You're going to open your mobile client and perform local device authentication according to the information sent to you by the server in the first place. So if it says I'm allowed to use passwords and fingerprint scans, then obviously you perform a fingerprint scan. That does the minting of the public-private key, so exactly the same as the FIDO spec here. And then it sends a message back to the server of the public key. You validate the challenge response against the user, and you send a message back to the phone saying we registered you okay. There's no communication again with the user agent at this point. It's completely unnecessary. You've said that you want to register and you want to associate this phone with your account, and you complete the registration using only the phone. You secure the secure store private key is associated with the server info, which contains the application ID, REST endpoints, for example, of the location to which you're going to subsequently send your FIDO messages, and the list of authentication mechanisms which you're allowed to use.
Sorry, just for clarity, the user device is like a laptop and the user mobile is like a mobile.
Precisely, yeah. So user device is your user agent is anything connected. I mean, they could both be the mobile phone, but if you think about the user agent as your web browser, basically connecting to any FIDO-enabled service. So then when you come...
Can I where the authentication service lives then? The third column.
Can I go back?
It's there.
It's here. It is here. This is the login sequence rather than registration sequence.
Oh, sorry. It was on the previous, but where does the authentication service live?
So this lives in the server.
Okay.
That's user land. That's user land. Server land. Sorry, I should have made that clearer. But websequencediagrams.com didn't allow me to do any fancy backgrounds because I'm a cheapskate that doesn't even buy rows. So the login sequence says hello, and here's the bit that differs from FIDO. Instead of the website simply saying, hello, I expect you to authenticate using your FIDO-enabled device, and I'm going to interrogate your phone in some kind of creepy JavaScript-enabled fashion, and also anything that's plugged into your USB devices and anything that's plugged into NFC, it simply sends you a message of a randomly generated PIN. It could be a randomly generated passphrase, and in fact the user could select this PIN and send it to the website themselves. Instead, the user says, I want to log in as user, and optionally, and anything in square brackets on this slide is optional, it says, here's the PIN that you just gave me, and here's my location. The user is required at this point to memorize the PIN. Ideally, this will be very, very short, 4 characters, 10 characters, something nice and easy, a well-known passphrase that you'd be easy to remember, and you'll only need to remember it for the duration of about, well, however long it takes you to get your phone out of your pocket, hold your thumb to your fingerprint scanner, and click send. So the website, the server tells its authentication module that this user is wanting to log in, and it verifies that user is registered. And then it simply says, okay, I'm going to await this user to sign in using their FIDO-enabled device at some point in the next 30 seconds, 2 minutes, 5 minutes, however long you want. Very lenient in terms of this. And optionally, you can say with a PIN and location. And I don't know if any of you have spotted why we need the PIN and the location, but the kind of easy answer to that is that if I constantly logged in at 9 o'clock every morning, because I work for a company that likes me to show up at 9 o'clock every morning, I don't incidentally, but if I did, then anybody that wanted to attack my account would simply have to know that I was going to log in at 9 o'clock every morning and use my username, and then wait for me to scan my finger when I was attempting to legitimately log in. That attacker would then have access. So to remove this, we add the randomness of the PIN, or the user-generated PIN, as well as optionally their location. And that means that subsequent messages will only allow the user that has actually communicated using the required PIN and is in the required location to log in. So you see that the server flow stops here after putting a await user signed in message with PIN and location into their service. Separately, you pull your phone out of your pocket, you perform, or you open the website location or service location that you want to connect to. So you say you click on Facebook, you perform your local device authentication, and you enter your PIN and allow access to the location information if that's required. It then forms again the signed message containing the user and optionally the PIN and location to the service endpoint, which was registered with it initially when it received the server info. Verify message and authentication method. And this channel here allows us to alter client settings. So in case Facebook have decided that they no longer want to use your fingerprint to allow you to scan in, but they do want to allow you to use your retina, then at this point you can send a message back to the client to say, actually your fingerprint's invalid, but update your local allowed authentication methods to include your retina. We'll assume instead that this was valid and that it looks good, and you send a message back to the user saying, well done, have a cookie, in a quite literal sense. So I've already gone through this slide by talking, but that's kind of the long and short of why SimpliFIDO, which you didn't even get the name right because of all the changes to the slides. The server configuration options are to allow a user-entered passphrase or a site-dictated passphrase, as well as enabling or disabling location restriction on the messages sent between the client and the server. Without these, in a single-factor environment, malicious users could spam login attempts during non-known login times. And I'm pretty sure there's a couple of videos, in case anybody likes watching videos that I didn't make and the ownership and responsibility of other people. Feel free to kind of Google FIDO knock knock or FIDO Samsung. They're quite new, these things. They haven't really matured very quickly, and they're still under development. The specs which I'm talking about, the official UAF and U2F specs, are still versions, I think 0.9 something. So they are still being formed. This is real emerging tech right now, and that's why I kind of want to bring it to people's attention, because it's really quite cool, I think. And that is the end of it. That is me talking, and I'm going to stop talking now. So, if people have questions, I'll try to answer them. I'd be happy to answer questions on FIDO or SimpliFIDO. Hello, sir.
Why would you use U2F over UAF? It seems like UAF has no other restrictions.
So UAF basically allows you to have this choice of how you're going to log in, whereas U2F gives you the kind of dumb FIDO client, so the simple card, the NFC enabled card that you hold next to your phone or so forth. I don't really know why you'd use either, which is why I've made SimpliFIDO. But I think the argument is simply that it's easier sometimes to carry around an NFC-enabled phone and hold a piece of card up to it than it is to go through the whole process of opening an application, scanning your finger, waiting for that to send a message over. Oh, hello.
So in this, assuming this great future,
yay!
Everyone's using SimpliFIDO.
Yay!
On my phone, I have like all my private keys to log into my email, to do everything. Right? Yep. What if I lose my phone?
Don't lose your phone. Just don't. As I said, there are mechanisms available, but as with any authentication service, if it relies on the storage of a private key or kind of local information, then you'll have to have a backup mechanism to authenticate with the service. Use hopefully UMA, which is user managed access, to remove tokens. UMA is another kind of emerging authentication thing that I won't go into, but essentially allows you to have control over your own access tokens. So you'd be able to say, I no longer want messages signed with this private key to be acceptable. So you just say, please remove the public key associated with my account from this.
Do you need a password to log into it?
You would have to use a password. Like, the fallback is always going to be, sadly, a password or a secret question, or but there is no way of, unless we build fingerprint scanners into people, there's no way that we can ensure against people losing their devices, unfortunately. So there's kind of always going to be a necessity to have some other form of login. The idea is, in the majority of cases, you will never need to use that.
Maybe a dumb question, but how are fingerprints stored?
They're not. Sorry, I should have made that really clear, actually. In fact, one of the most significant parts of this spec is that the fingerprint isn't stored, isn't transmitted, never goes across the web. You're not sending a copy of your fingerprint over to the server to analyze and verify that it's you. All you're doing is using Touch ID, or whatever the Android implementation that's not Touch ID but totally is Touch ID, to say yay or nay to your fingerprint being read. And all that allows is access to a local locally stored, secure stored private key. The actual mechanism via which fingerprints are stored, all I know is that on Apple's devices they're stored in their own dedicated hardware, which has supposedly lots of protection and is hard to get out. I don't know / care about that side of things, and that's kind of the great level of abstraction that the FIDO and SimpliFIDO specs give you, is that you don't need to worry about how they authenticate on their local devices, simply that they have authenticated.
Yeah, I mean, I get that. It's nice not knowing that your fingerprints are so much, but I imagine that I can't do a retina scan on my mobile phone. So at that point,
Maybe not now.
Do you think there's going to be lots of crimes for people getting their fingers chopped off?
Yes, I hope so.
I'd rather people like nick my card than nick my finger. You know, that's I think the count as some of these biometrics stuff.
I think I'm not trying to stop people being bad people. I'm just trying to help introduce better authentication mechanisms. I mean, if somebody's going to go to the extent that they're going to torture you to get you to tell you their password, then they'll cut off your finger. Yeah, but and they'll steal your phone while they're at it. It does seem a bit moot, though.
Well, I'm not sure. You get mugged, get taken to a cash machine, and they just nick how much cash you get out. Whereas they chuck your fingers off,
Just check for pulse. Just check for pulse.
Check for pulse.
Oh, right.
Which is really easy to do.
That's a good answer. I like that answer. Just come up and give a talk on this stuff.
take it into a piece of plastic or whatever, and then you've got a pulse and the right fingerprint. So, anyway, I'm not picking pulse now.
No, please do. I mean, you would, for example, the FIDO spec allows you to say you need both your fingerprint and your retina and your password all done on your local device before it will release the key. There's as much flexibility as we can give, but we can't stop people being criminals. That's kind of out of scope of it, unfortunately.
Does the you've got an implied hierarchy of authentication mechanisms that are built into the FIDO client.
Yeah.
Is there in fact a hierarchy, or is that just up to the
It's up to the server implementing the server side
decide what to accept
and what not to accept. So they could say, I accept it that you've used your password to unlock your phone to be your authentication mechanism.
And what I mean is the FIDO Alliance keeping a register of types? Because if someone's inventing a new piece of hardware that's a brainwave scanner,
right. Precisely, yeah. So there are hex codes which the FIDO Alliance have said this is the fingerprint scanning, this is retina scanning, this is face recognition, this is password, and they'll just add more to those as you go along. But
it's not ranked.
No. It's not that your fingerprint will override or be more powerful than your password. It's up to the servers to, as you say, if you want them to both use a password and a fingerprint, then in the message that you send to the client, you say, I require you to use both this and this before you unlock the private key.
So that means that if you allow the authentication against your device to be even just simple password, I mean the whole system is as weak or as strong as the way to
Well, you still have the ownership level of being required to have the device. So the ownership-based authentication, the second factor is still there. But yeah, you're correct that there is kind of no... if you implement the entire spec and then say you only need to use a password, then you've slightly defeated the purpose of it. But the flexibility inherent in the system is still there for another engineer to come and fix that mistake.
You just don't increment the security, you just you improve the mechanism.
Yeah.
And arguably, if you're a host, a server, you could allow the user when they create an account initially on your site to say, I have these mechanisms and I'm only going to accept that when I try and log in using my retinal scanner, that's only going to, the user could decide.
I mean, that would be in addition to the spec. That's not part of it as written, but a server would be easily able to add that to its own implementation, yes.
You seem to be implying an awful lot of trust in the app running on the phone.
Yes.
Obviously that's susceptible as well. So.
Yes. So these are signed and registered with the FIDO Alliance as vendor IDs. There's kind of vendor ID, hash, app ID, and the app ID contains the kind of a hash of which authentication mechanisms that app will be able to provide back to the client and back to the server, and that's the message that's sent back to the server. The server can then query the FIDO REST endpoint to say, is this a valid application? So is this actually a Samsung FIDO client?
And are people supposed to trust that the NSA hasn't got hooks into that?
Nobody's supposed to trust the NSA. That's why I wear the T-shirt. Insofar as governmental privacy concerns, again, sadly, somewhat out of the scope of this, as is stealing fingers. If it's been infiltrated and there's some cunning, code in the spec that transmits everything over to their wiretapping houses, then more power to them, I suppose. But
is it a requirement though that the authentication apps on the user device be closed and proprietary? I mean, is it the case that if that app was open, you'd be able to reverse out a way to circumvent it? Because if the client app could be open source, then we could be establishing whether or not it was doing something improper. Some mechanisms require the client app to be closed. Like you can't get an open source PDQ terminal.
Okay.
It's actually very similar to this process.
Not that I've read or know in the spec, although it could well be in there, but I'm afraid I don't know in that level of detail.
Presumably, if it's an open spec, anyone can write an open source.
That's what I would.
Not if they have to be signed and approved.
Yeah,
by
Yeah. So that would be the restriction with regards to that. Sorry.
This might not make any sense at all. If
did the presentation?
If the server says, okay, these are the authentication mechanisms I will allow you to authenticate yourself with, say fingerprint and retina or whatever, and then there's multiple vendors that offer hardware retina scanners, whatever, say, if a vulnerability comes out in one of those hardware retina scanners, can the server say, okay, I don't want to allow that kind of retina scanner, but
yes,
I'll allow the rest?
It would be able to use the registered application ID, and as I say, the application, the client application is split into two. So the first part is basically a hardware code that says, I am a Samsung Galaxy S3 and my capabilities include a fingerprint scanner and a camera of X megapixels. And then the part after the hash symbol then says, these are my current capabilities as per the software that I've been given. And the server would then be able to go to a lookup table to say, actually, this has a vulnerability in it. I'm not going to accept any authentication responses from this device. I'm going to tell them to log in using a different mechanism.
Sorry, just another quick one. Has this come out of research to say that X billion people will be protected better, or is this a convenience thing? Is this it's more convenient for me to log in something if I've got my phone, or is there a lot to suggest that this will cut credit card fraud or whatever? What's it come from? Is it what's driving it?
I think the driving factor is the desire to remove passwords, quite frankly, because people are inherently the weakest point when it comes to passwords because of their reuse. As for what triggered Google and Knock in the first place, perhaps the desire to get me to say their names to a group of 100 developers so that you buy their products, I'm not sure.
Is it the case principally that SimpliFIDO is principally addressing the problem with vendor acceptance?
Yeah. The entire and only point of SimpliFIDO is to allow you to implement it on any device without having to worry about the user agent being smart, and also to not have to write any JavaScript.
So have you considered, I don't know whether this is possible, approaching the Alliance and saying, look, you're not going to get Apple on board anytime soon, but for those people using Android devices for which UAF is terribly convenient, let's implement that, and let's also build into the protocol SimpliFIDO, so that if you find that the client device doesn't have the FIDO stack built in, we back onto SimpliFIDO, and then you get the best of both worlds.
That would be ideal. And when I have the example SimpliFIDO apps up and running, which are unfortunately still in development, I was hoping to be able to demo them today and log into an AM protected website, which I could have set up, but sadly the
business model,
code's not finished.
That would suggest that Apple users would in fact still, site owners looking for improved security and reduced number of instances of hacking would benefit from, all the Android users and so on, and Chrome users would immediately benefit. And there'd be pressure on Apple because their users would be getting these bloody 4-digit PIN codes all the time, and they'd be pressurising Apple. So you've got a mechanism there to actually get Apple to come on board.
Yeah, I mean that was essentially that wasn't the justification. As I say, my idea of SimpliFIDO was simply to allow it to be used everywhere. But if that becomes an argument to allow to pressure Apple or FIDO Alliance to do these things, then that would be wonderful. As it stands, I should make this clear. My affiliation with the FIDO Alliance comes insofar as I work for ForgeRock, and we happen to be a partner of the FIDO Alliance, and that's because some guys in America go to some meetings and are very good at networking. My actual ability to talk to the guys that run the FIDO Alliance is restricted to whatever public email they have in the same as anybody else. But yes, I'm hoping to actually have, as I say, a working live demo of SimpliFIDO within the next couple of weeks at the latest.
Cool.
Could you explain the necessity of having that pin again? Because I couldn't see the vulnerability.
Okay, so I am in, I work for Oracle. I don't actually work for Oracle, but I work for Oracle, and Oracle like me to wear a suit and come in every day at 9 o'clock. And every day that I'm not ill, I always log in to their authentication site using the same username, which is comprised of my first name dot my last name. Really easy to guess username, and they require SimpliFIDO to log in. But SimpliFIDO doesn't require you to have this additional PIN or this additional location restriction sent in the message. So when my malicious Chinese hacker that really wants access to my Oracle account goes to my website, they wait until 9 o'clock in the morning and they say, I'm logging in as David.Luna. And 2 minutes later, they still haven't actually completed the login process, so they say, okay, I'm logging in as David.Luna. And they keep doing that. Now, insofar as the server knows, without any additional piece of information, such as a PIN or the location, there's no way for the server to allow or deny any specific user attempting to log in as that username. So when I go and sit down at my terminal at 5 minutes past 9, and I say, I'm David.Luna, and it says, do your FIDO thing, I pull my phone out and scan my finger, that'll log in both me and the guy from China.
Why would it log in the other guy?
How would it not know that the other guy isn't me?
Because there's one connection to you and there's one connection to him.
But the phone sent a message completely independent of the user agent. This is the thing that FIDO addresses by having the smart user agent.
Right.
So in FIDO, the user agent proxies the message to your device, which means that they know that you have the device on you, on your person. I'm trying to get away from that, so to alleviate this, we need some entropy, we need some randomness that only the user that's logging in at that time knows. Ideally, I'd like it for the users to choose their own randomness, so they say, I'm David.Luna and today I'm going to log in with the lyrics from The Doors' Touch Me. And then they go to their phone and they type in the lyrics of The Doors' Touch Me and scan their finger and it sends a message. But because they'll always use the words to touch me because they're idiots and they'll just keep using the same thing over and over, it's far more sensible for the server to tell them, look, your digits are 6632.
So what's the advantage of this scheme over something like Google's two-factor authentication?
The local device and pluggable device authentication. So it's a framework that allows for any subsequent authentication mechanism that comes thought up that becomes available on a phone to be enabled. So currently you don't have retina scanning on a phone, or if you do, you probably need an incredibly high megapixel camera to be able to do that. When that becomes commonplace, if that becomes commonplace, then that's something that you'd be able to add in as a mechanism on the spec without having to change the spec at all. Whereas Google's one-time passwords and things are restricted to, we're going to send an email to a location and expect you to have ownership-based authentication via accessing that email.
Is there which, you know, the thing that I think is great, really fantastic, well done, all that stuff, brilliant, love it.
Cool, stop that.
Also the bit about remembering the PIN or the lyrics and so on, not only does it make it slightly more cumbersome, but I can imagine classes of users, limited accessibility and so on, who will just kind of go, this is shit, I can't use it, I've got to do all this extra stuff again, it takes away the benefit.
Yeah.
I mean, what about things like just the server generates a QR code, you get your camera out, your phone, and you take it, and that's effectively doing the password. But I can't see why that would be bad, for example. It's only your attempt to log in, it sends you QR code, you take a photo, that confirms it's my device in this location, and then you do your thumbprint and you're done.
talk to me afterwards. But that kind of thing is the idea of the passphrases and location restrictions again are also pluggable. Yeah. So in the spec that I'm working on anyway. So technically that would be feasible, although not in the current implementation. But yes, that is.
There's a whole class of things like that, aren't there?
Yeah. That's a very good point. And accessibility is not something that I've thus far really considered, because I'm a privileged white male, aged 18 to 35.
It's okay.
Talking about that, how accessible are these kind of things for people with disabilities? Or were you just talking about that? I just didn't get it. Like, if you can't see, for instance, or
yeah, I mean, I'm not sure.
But this is really good.
Again, somewhat out of the scope. Although
this is really good because it's pluggable. We don't need to know what devices are good for limited accessibility people, but there are mechanisms. And if they plug in to the pluggable section, you're good.
So all the device would need is a mechanism of storing a private key securely, which would probably need some dedicated hardware, but so long as that's there. And then obviously the service that they're trying to connect to, if there's a Braille version of the website that they're going to, or there's some kind of read aloud version, then that would fill the necessary requirements for them to be able to actually communicate with the site. But again, those are general W3C style accessibility problems and not something that I'm trying to address.
Yeah, I know for them it's like an obvious convenience they might not need to.
Yeah. Hello.
I would imagine that if you get some kind of you get a notification on your phone that you try to log in and then you receive a message on your phone showing that code that you have to type in. I would imagine that would be the process, right?
So in FIDO, in FIDO there would be no need for a PIN to be sent to your phone because the user agent is able to talk to it directly. In SimpliFIDO, there's no communication between your browser, your user agent, and your local device.
No, but the server sends a message to your phone.
No.
Sending you those four messages.
So in the very first case, the back channel communication in registration occurs via any other channel of communication, so it doesn't rely on you being on the same Wi-Fi network. It can send it over SMS, and the reason it can do that is because all it's sending is essentially a scheme which is locked on your phone to opening the FIDO application, and a piece of text which is base64 encrypted or whatever, which contains the server information, which is all public information.
Yes, so that's what I understand. So when you log in with SimpliFIDO, the server will send a message to your phone saying that, okay, here's your PIN, and then you take that PIN and then you type it in the browser.
No, only when you register does the server send a message to your phone. The subsequent logins don't require any message sent between the server and your phone, only a message sent between your phone and the server.
Okay, so you have to proactively do that?
Yes.
Okay,
yes. So the process would be go to Facebook, type david.luna, pull your phone out of your pocket, click SimpliFIDO 4-drop app, click Facebook, scan my finger, and then type my PIN, and then click send. That would be the entire process, and in that time the screen would then go whir, plink, and as soon as it goes plink, you're logged in.
So you wouldn't be nagged with messages because people
No. Push notifications and buttons and all that stuff is not what we want.
But to be clear, the authentication device has to autonomously be able to communicate.
Yes, so it does need to be web enabled essentially. It does need to be able to talk to the server.
Whereas something like the Google two-factor time-based thing requires only you to enter a number into your web browser that's already connected to the network by definition, because that's the thing that you're trying to... Is
that a time synced?
It's a
time server synced device, yeah. So,
but you could presumably generalise that to any device, any mechanism. The mechanism would verify by whatever means and produce you a code that was...
yeah, I suppose... I suppose you could on the local device generate some information that then the user would have to type in to kind of be a symbol of that they locally authenticated. Although it's somewhat more.
I have a real dislike of devices having to autonomously be able to communicate.
Okay.
Because I mean it's all very well in California, but doesn't always work. It's like, you know, I'm in a hotel, I'm out of range, all I've got is this Ethernet connection.
Yeah.
My phone doesn't.
I entirely understand that, and it's a very good point. It's something that I'll try and take into consideration for further kind of mechanisms for allowing SimpliFIDO to expand. But in its initial base, I really do want it to be the simplest possible version of a pluggable local biometric auth app system.
Right, we're going to stop there because I didn't realise what the time was, and we've got 10 minutes to eat this lovely food. Okay. Yeah. So, thanks very much.